Hello everyone, my name is Dan the Tutor, and today I am joined with Darshan from tutoringmathy.com. Today we are going to be doing a challenge. We are going to be giving each other AP Calc 1 or Calc AB questions, one each. The goal is to basically see if we can solve the question. I designed mine to basically be difficult enough where most of my students would not be able to solve it, but obviously someone like Darshan should be able to. So that's my goal. Hopefully his question's not too hard for me. Hopefully I don't get stumped because that would be embarrassing. But regardless, Darshan, why don't you give your second to introduce yourself?
My name is Darshan, and I'm the founder of tutoringmathy.com. I've been an online tutor for about 8 plus years. I teach math and physics primarily, but of course, it's great connecting with Dan today, and this exchange of questions is going to be intriguing. So let's see how it goes.
Okay, great. So to determine who goes first, we are going to flip a coin. Okay, so I'll let you call it heads or tails.
I'll go with heads.
Okay, and it's heads. So you go first. Would you like to give the question or receive the question?
Um, I will give the question.
Okay. Okay. So do you want to read it to me or do you want to share screen?
I will just share the screen. You can probably screenshot this.
Yep.
All right, there you go.
I'm going to, just looking at the picture, I'm going to guess it's an optimization question.
Absolutely. Well, spot on.
Yep. The Norman window. I've never heard of a Norman window before calculus, so but now I do. So a Norman window is constructed by adjoining a semicircle to the top of an ordinary rectangular window. See figure. Find the dimensions of a Norman window with a maximum area if the total perimeter is 16 feet. Okay, now quick question, I guess two questions for you before I get started. Number one, am I allowed a calculator for this? Okay, got it. And second question, that bar in the middle is part of the perimeter, correct?
No.
It is not.
This bar is not a part of the perimeter.
Got it.
Nope.
Okay, great. Okay, so then now I'll share screen and let's do it.
All right. I'll unshare. Shall I unshare mine?
Yes.
All right. Got it.
Okay, so first let me draw a picture again. And it's got the semicircle top, famous Norman window. This side is X, this side is Y, and they give us that this is 1/2 X. And the reason why that's important
Exactly.
is because that's going to be the radius of this
Oh,
semicircle.
semicircle. Absolutely.
Okay, so then the perimeter is 16 feet. Was the units feet?
Yeah, it is 16 feet. Yeah, that's correct.
Okay, good. So the way I always start optimization, I like to do an objective and a constraint equation. The objective being what the question's asking for, in this case, maximizing the area. So my objective is going to be the area formula for this Norman window. So really I'm breaking this up into two shapes. Number one, a rectangle here in red, and number two, a semicircle here in blue. If you don't have the equations for, semicircle and rectangle, first of all, they're not too hard to memorize. You can memorize them. I forget, Darshan, do you know if it's on the AP exam, these equations?
Unfortunately, not in APs. We are not given any equation sheet, unlike AP Physics. So,
Yeah.
well, we have to go the hard way. We have to memorize.
Yep, exactly. Okay, so objective's going to be rectangle. Area of a rectangle is length times width, in this case, x times y, plus the area of the semicircle. A circle, if you remember, is pi r squared. So in this case, it's going to be just 1/2 pi r squared for the semicircle.
Exactly.
And
Exactly.
I am going to plug in radius. The radius is, like we said earlier, 1/2 x. If you did not know that, well, then you're a little bit in trouble because we need to know that. Also, I need, I guess this is more notation. I'm going to call this A equals for my function because it's area. If you miss that, not a big deal,
Yeah.
but I like it for notation. And then the objective and constraint. So the constraint equation is the thing that's basically limiting us. In this case, it's the number, perimeter 16 feet. So that's going to be the perimeter, which is going to be, I'll highlight it in green. It's everything except the bar in the middle. The reason why I asked that question at the beginning is because I've seen it both ways, where sometimes they include the bar in the middle, sometimes they don't. I always get confused, and sometimes I find out as I'm doing the question that I've been doing the whole question wrong. So better to figure out
Exactly. That is, I absolutely agree. It's good that we clarified that.
So then from here, the perimeter is going to be this side at the bottom is x. So x plus the two sides on the left and right is y plus y, or just 2y. And then now for the semicircle part, again, we need the perimeter of a semicircle, which you may know as circumference. Circumference is normally 2 pi r. But again, since it's a semicircle, we're just going to remove the 2, and so it's just pi r. So I'm going to say plus pi r. Again, the radius is 1/2 x. I'm going to be putting 1/2 x right there. And then finally, you set this equal to the perimeter, which we said was 16. Okay.
16.
So we've done, honestly, the hardest part of the problem right here, in my opinion, because objective and constraint, some people call it primary and secondary equations, is the only part that's different for every optimization problem. In other words, everything I do next is going to be basically the same thing every time. So I have to choose to solve my constraint equation first. I get to choose between solving for x or for y. I'm going to choose y here because there's two x's, meaning it's harder to solve for x. So the way I do that, first I will subtract x and 1/2 pi x from both sides. So in other words, 2y equals 16 minus 1/2 pi x minus x, and then just divide by 2. Y equals 8 minus 1/4 pi x minus 1/2 x. There's a couple ways you can do that. Another way is putting the whole thing over 2, but I like distributing the basically 1/2 more. Okay, now what we do is we plug in this y into the y right there. So area equals x times big quantity, 8 minus 1/4 pi x minus 1/2 x plus, okay, I'm going to simplify this a little bit here. 1/2 x squared, don't forget, you need to square both the 1/2 and the x, making it 1/4 x squared, and then still a 1/2 pi out in front. The next step involves finding critical points, taking derivatives, stuff like that. Before you take the derivative, I highly recommend simplifying as much as we can. So area equals, first distributing that x right here, 8x minus 1/4 pi x squared minus 1/2 x squared, and then plus the stuff over here. That's going to be eighth, because 1/2 times 1/4, 1/8 pi x squared. Now part of me was hoping that this here and this here would cancel. Clearly I'm not so lucky, but that's okay. I can at least reduce it. So 8x, that's going to be minus 1/8 pi x squared, and then minus 1/2 x squared. So at this point I've got everything ready to go. I'm ready to take the derivative and find the critical points. So the derivative of this will be, this is an easy, just coefficient rule, 8 minus, a lot of people get tripped up by this pi. I am not going to be tripped up by it. It's just power rule, and the pi is a coefficient. It's not product rule. That'd be bad. So it's going to be 1/8 times 2, so 1/4 pi x, now to the first, so I don't need to write it. And then minus 1/2 times 2, which is just 1 x to the first. So this is going to be my derivative. I'm setting this equal to 0. And now I'm solving for x because I want the critical points. That's going to be where the maximum area occurs. So this one's not going to be fun, I'll tell you right now. I'm going to start by adding the 1/4 pi x and the x to both sides to keep it positive. And then what I have to do is I have to take out the GCF, greatest common factor, which is x times 1/4 pi plus 1. And then you just have to divide. So this is why I asked at the beginning, do I get a calculator? Because this is
Exactly.
a little bit of a nightmare to do right here. Now, personally, this is a personal touch. I do not like complex fractions. This is a complex fraction with the 1/4 right there. I don't know if this is optional or mandatory. Honestly, I think it depends on who's grading it sometimes. But I'm going to multiply by 4/4, which is just 1. And the reason why I'm doing this is it's going to eliminate the complex fraction in the denominator. Okay, so
Perfect.
here's my x for the maximum area. Although technically I don't know it yet, I still have to prove it's a maximum. I can do that with one of two ways, either absolute extrema, which involves plugging in this number and the bounds into the original function for area, that's called absolute or global extrema. However, I'm going to do relative extrema because I like that more. Relative extrema involves doing the first derivative test, so that means plugging in my critical point on a number line. This number line is technically bounded. It's bounded on the left by 0. How come? Because you can't have an x or a distance less than 0. And there's technically going to be an upper bound, but it doesn't matter, and I'm just going to be careful with the number I plug in, and I don't have to worry about that. So 32 over pi plus 4, even though I don't have a calculator, I know that's about 32 over 7, because pi is 3.14. So I'm just estimating here. 32 over 7 is going to be a number around 4.5-ish, because it's between 4 and 5. And you can, do that in your head, or you can at least say, well, this number is greater than 1, but less than 10. Like, there's a lot of different ways you can do that here. So for the number that's less, I'm just going to choose 1. Very easy number. But what am I plugging 1 into? I'm plugging into the first derivative, which was 8. Yep, right here. 8 minus 1/4 pi x minus x. 8 minus 1/4 pi x, where x is 1, minus x, again, x is 1. And I don't care about the number. I just care if it's a positive or a negative number. Now,
Exactly.
pi is again 3.14. I'm just going to round that to 3/4 minus 1. I don't know. I mean, I can figure it out if you just give me a minute, but I just know it's going to be positive, and that's all I care about. So I'm going to put a positive right here on the number line. I'm already going to guess that this is going to be negative, but you should never just guess. You should always plug it in just to make sure. And I basically need to plug in a number greater than 4.5. I'll choose 6 just to be safe. So 8 minus 1/4 pi times 6 minus 6. So that's going to be 8 minus, again, pi is about 3. This is about 18/4. And 18/4 is really 9/2, which is really 4.5 minus 6. So again, even though I don't know the exact number, I know this is definitely going to be negative, like I thought it would. And by the way, this is a very good sign, because as you can see, positive followed by a negative, that is going to be my relative maximum. In other words, I just confirmed that 32 over pi plus 4 is my maximum for x. Okay, so we have x. X equals 32 over, I think it was pi plus 4. Yep. 32 over pi plus 4, that is feet. And those of you building your own Norman window out there, of course, this is exactly the math you would do when you're building your Norman window one day. So, but don't worry, if you're not smart enough to figure this out on your own, you can always hire someone like me or Darshan to help you, and we will gladly do it for you. So this is going to be my x. And then the y, how do I find y? You just plug it into the constraint. Going way back to the beginning of the problem, we said y equals 8 minus 1/4 pi x minus 1/2 x. I'm going to forget that, so I'm going to scroll up a lot and down. Y equals 8 minus 1/4 pi x minus 1/2 x. Was that it? Let's see. 1/4. Oh, look at that. Okay. So here's y. Finally, you just plug in this value for x. Y equals 8 minus 1/4 pi 32 over pi plus 4 minus 1/2 32 over pi plus 4. Simplifying this, it's going to be 8 minus, You can reduce the 1/4 and the 32 to give you an 8 in the numerator. This pi stays in the numerator. By the way, if you try and cancel out this pi and this pi, that is highly illegal. You cannot do that because of the +4 right here. If that +4 was not there, then you could cancel it out. But, we can't have nice things in life. But we can have a Norman window with the maximum area. So there's the trade-off. And then 1/2 times 32. Again, I'm reducing these to give me 16 over pi plus 4. Since it's the same denominator, I can at least rewrite it as one fraction. And I'll put the negative sign out in front, meaning that all my negatives turn to positives because I'm distributing that negative sign. So a lot of the algebra here is really annoying and tedious, but the actual process, finding the objective, finding the constraint, finding critical points, finding relative extrema using the first derivative test, these are all things you should know. And I believe that's it. Did the question ask for the maximum area or the dimensions?
That's it about the dimensions, and it was spot on.
Okay. Well, there we go. So that's going to do it for Darshan's question. Not hard enough, which thankfully...
I don't know, which makes me nervous now, because that was pretty smooth and well explained. Now, let's see. I hope that was an easy one.
So I'll tell you this. Mine is also more tedious than difficult, in my opinion. There's also two ways of doing it. I'm curious which way you take it on. So let me share screen, and then I'll let you share screen.
Go ahead. Got it. Yeah, I took the screenshot.
Okay.
I have the question. Let me just put it on my board and then share my screen. All right, okay. Right off the bat, I can see that the question is obviously asking for the slope of the tangent line, and a point is given, which is pretty nice because now I'm thinking about point slope form. But it's just the slope of the tangent, which is derivative, because derivative is the slope. And after doing the derivative, I need to plug in x as 0 and y as -16. I don't think so I need to put the y, because this is not an implicit differentiation. It's just an x. Now, the question is, if I'm going to differentiate this, it's going to be horrific because there is a quotient rule, and on the top there is a hidden product rule as well, and I do not want to do that. But thankfully, I remember if I take natural log on both the sides, then I think it's going to break into some additions and subtractions, and the rule for those are not as bad as the product and quotient. So I'm going to try to do that, and let's see if it works out. Just for the convenience, I'm going to say fx as y. So I'm going to say that y is equal to x plus 4 whole square, 2x minus 1 whole cube over natural log of x plus e. Obviously, you might be thinking that there is already a natural log in the denominator. It's fine. It's going to turn out fine. I can just see that it's going to turn out fine. So don't worry about that. All right, like I said, let's take ln on both the sides. So I'm gonna move this guy right here, and okay, all right. So I'm gonna take natural log both the sides. So it's gonna take ln y is equal to ln of this entire gross thing, which is x plus 4 whole square, 2x minus 1 whole cube over ln x plus e, and a big parentheses just to contain this thing. I'm going to forget about the left side because it's a ln y, ln y, ln y. It's just going to repeat itself. So don't worry about that. Now, what is log of a over b? Although I say a over b, in my mind, I know that my a is the entire top thing and b is the entire bottom thing, right? And although I'm saying log, the properties are equally valid for ln, because ln is log with base e, right? That's a log after all. So I'm going to say log of a over b is log a minus log b, if you agree. So log of a, and remember that a is again that big product. I'm going to contain that once again, minus log of or ln of b, which is this. It's fine. It's a double log. Don't worry about that. It's totally fine. All right. I'm going to make some space. So What is log of a times b? Is that log a plus log b? I'm going to do that because this is a for me and this is b for me, right? So I'm going to say that it's log of a plus log of b. All right, perfect. And this ln remains as it is. That's fine. Okay, another property ringing in. Do you think whenever we have these inside things raised to some powers and there's a log sitting outside, then basically you throw these powers outside, if you remember, right? That's the property of log. So I'm going to do that. I'm going to say that ln y is equal to 2 ln x plus 4 plus 3 ln 2x minus 1, and this our double log guy remains as it is. All right, do you think we can simplify this further? I don't think so. I think we have done everything that we could. So I'm going to now differentiate both the sides because we already agreed that we are looking for a slope of a tangent line, and the slope is y prime, of course. Now be a little careful when you're differentiating the left side because that's going to be an implicit differentiation because that's a y, right? Some students make a mistake of just writing 1 over y and then they are surprised that, hey, where is my y prime? Yes, when you differentiate ln y as per the rule of ln, the 1 over the inside thing that comes out, and then you differentiate y in terms of x, which is of course dy over dx, but I'm not a big fan of writing dy over dx. I'm going to just write it as y prime. All right, let's break these guys down one by one. So 2 ln x plus 4, obviously 2 is a constant that safely comes out, and the derivative of ln x plus 4 is 1 over the inside thing. So it's 1 over x plus 4 plus likewise 3 over. Now this is where there's a pitfall. Some students might just stop here, but no, it's a chain rule because when you differentiate ln, it will be 1 over, totally fine, but you're going to go inside and breach this thing as well. In other words, you're going to differentiate 2x, which is going to return you 2, and 1 is just 0. I don't have to worry about that. And okay, here could be confusing. Let's do it step by step. Ln of something, right? Let this something is what I always read as ln of something, and ln of something derivative is 1 over that something. So this something, whatever it is, it's going to come down. So 1 over ln x plus e, but we are not done yet. We have to again breach inside. So this is down. Now you have to break this law, which is again 1 over the inside. But what is the inside this time? It's x plus e. All right. So it's be 1 over x plus e. And I think we have breached everything because x plus e is just 1. And I'm not really a big fan of writing tangents on because that's the same thing. And now, earlier I said I won't be needing y, but actually I need y because there is a y here. So can we decorate? Honestly, I don't want to decorate this because I'm not leaving an expression, right? I'm just putting, after all, x as 0. So let's put x as 0 first and y as negative 16 and then try to decorate because personally it's easy to decorate constants versus variables. So I'm going to do that, but of course I'm going to multiply y both the sides so that this y prime is just left alone. I'm going to put a big parentheses over here. So 2 over x plus 4 plus 3 times 2 is of course 6, 6 over 2x minus 1, and this is just as it is. So uh, if you don't mind, I'm going to write x plus e first. It doesn't really matter. Times ln x plus e next. Okay, so far so good. Now, what was x, guys? That was 0. What was y? It was, again, forgot, 16 or negative 16. So negative 16, I'm going to write that here. And now let's plug in these numbers. So y prime is going to be negative 16 parentheses. Now, it's lucky for us, we just plug in x as 0. So 2 over 0 plus 4 is 2 over 4. 2 over 4 is 1 over 2. Good. 2x minus 1, x is 0, 0 minus 1 is negative 1, and 6 over negative 1 is just negative 6, right? So I'm just going to write negative 6. Now, x is 0, 0 plus e is just e, and ln of 0 plus e. And what is ln e? 1, right? Another way to understand this is log of A with base A is just 1. So ln E is basically log of E with base E, which is just 1, right? Right, so it's good for us. Y prime is equal to negative 16, 1 half minus 6 minus 1 over E. Of course, um, we can simplify this, I think. I'm gonna take a common denominator as 2E, if I'm not wrong. So this is gonna end up with E. This is gonna end up with 12E, right? And this will end up with negative 2. I hope I'm right. E, 12E, and negative 2. I hope so. So y prime will be equal to negative 16. E minus 12e is negative 11e minus 2, double negative. But yeah, good for us. There's a negative outside. It's going to make everything positive over 2e. So finally, I'm going to say that y prime is equal to, oh, by the way, 2 times 8 is 16. So negative 8, at the same step, I'm very, uh, it's very tempting to take this negative sign inside. So I'm going to do that. So 8 sits outside and this negative goes inside, ramps into both the terms and makes it positive. So 11e plus 2 over e. And I think we should call it a day.
I'm happy with
I
that.
mean, we can, let's call this as our slope. It's not nice, but it is what it is.
Yeah, perfect. The only thing I have to say is at the beginning, it's a lot of people think that you need the whole equation of the tangent line, but nope, always read the question. Don't make extra work for yourself. This just wanted the
That's
slope.
correct.
And then, yeah,
It's
this is
correct indeed.
definitely the better way of doing it, the logarithmic differentiation method. If you don't do this, Darshan, what do you have to do as the long way?
Um,
Besides cry.
well, then we have to apply multiple rules.
You
One is
don't
the
have to go through the
quotient
whole
rule.
thing. You can just do maybe just say it.
Exactly, exactly. It's gonna be denominator low square, low d high minus high d low, and remember the high is already a product. So inside a quotient there is a hidden product, and after doing this once, I'm pretty sure you're gonna leave this question. So not a good idea. Follow the log thing. It's gonna contain this question then.
Yeah. And I'm impressed you didn't even flinch when you saw the double natural log inside the natural log. You knew exactly what to do, which
Exactly.
you probably won't see that on an AP test because I've
That
never seen.
that is actually very true because I was like, okay, log, another log. But then I thought that eventually I need to put x, and I think I mentioned this because I'm not bothered because I said that if I put x as 0, it's ln e, and hey, ln e is a happy number, ln e is 1. So that's why I was like, I think yes, I'm going on the right track.
Yep. And then finally, like you don't get natural log of e equals 1 on the AP exam, so you just need to know that one. You also need to know a lot of
Exactly.
your trig, like sine of pi, cosine 2 pi, stuff like that.
Absolutely.
But yeah, you
That is
crushed it.
imperative.
You crushed it.
I am happy that I did.
Okay, well, that's all the problems we have for today. This has been the Tutor versus Tutor challenge, or whatever I'm going to call this. But yeah, Darshan, thank you for joining me. That was a lot of fun. And I
Thank
hope to
you.
see
Thanks
you
for
again in the
inviting
near
me.
future.
Yes, please. All right. I'll see you soon.
Sounds good. See ya.